That's what you say every unit.
This one's really a lot of fun.
That's what you say about a lot.
And now I'm going to show you, once we finish writing down our learning target, I'm going to show you the full power of the foldable because we're going to be using all of it. Does everybody have their learning target written down?
Yes, ma'am.
Okay. Let's hustle.
Hey, it's a W.
So while we're waiting on people to write down the learning target, who can tell me what an exponent is?
Oh, a number that's multiplied repeatedly by itself.
Kind of.
Okay, I think that.
Braden?
It's like the square and the cube, the little number on.
It's the little number on top, right? So it's what both of you are saying, but it's putting it together. So that's what we're going to talk about today. Now everybody get ready to open their foldable. So we are going to open it like this. And then you can open it like this. And then you can extend it so it has the whole thing. Now close it. Close it so you see your name.
Okay.
And then open it this way.
Oh my God.
I know.
Hold up.
It's the greatest foldable we do all year.
Mind blown.
I know.
Where are you closing it to see your name? Right here. You open it. Oh.
I don't want to know. I don't want to know.
No.
All right, so what we're going to do first, guys, is you're going to open it like this, and then you're going to turn it.
You did it right.
Wait, which one did you say?
Open and turn. No.
Where's the name?
All right, children, look back at the board. Look back at the board. You should see your name.
You did it right. Yeah. Oh, I did it right.
Open it this way, just the first flap, and then turn it to the right.
Oh, dude.
Mind blowing?
It's all messed up.
All I did was turn my paper, Mitchell. That's all I did was turn my paper. Okay. All right, so we're going to write down 3 questions. The first question said, what is an exponent? Now you need to leave some space between each of the questions. The next question is, what is a base? And the last question, what are the properties? And these arrows point to what the properties are. We're going to be writing those down in your colored blocks and your white blocks.
I'm sick of questions. So, title, open it up, right here.
Yes. Okay, y'all are about to cause us to have to get whole new groups. Like, y'all just can't sit together. I understand, but y'all just can't sit together. Yes.
Could I have Mitchell Bailey to the main office?
Yes, ma'am. Alright, so, an exponent. Is it the big number or the tiny number? It's the tiny number. Alright, so it's the small number. The small number. And what does it tell you to do?
Multiply the big number.
Multiply it by itself.
Multiply the big number by itself, alright? And it tells you how many times, correct?
Yes.
So if it said 4, how many times should you multiply the base? What if it said 75?
75.
What if it said donuts?
Donut.
Look at us go.
I'm going to
Alright? That tells you how many times to multiply the base by itself.
Ooh.
Look at you go. So what's the base?
The
The big number under the little number.
The big number under the little number?
Yeah.
So could we say the big number by the exponent?
Or by the little number.
Oh, okay. It's the number by the exponent.
The number you mean under it?
Oh my God.
Well, it's kind of like a
Just-
it's like
nope.
diagonal.
Just
It's under it. Okay.
so can a base be a variable?
Yes.
Does it have to be a number?
No.
It could be a variable.
Totally variable.
So if I said e to the 9th power. Now, do I say e9 or e to the 9th power? E to the 9th power. What if it was a 2? What would I say?
2 times 9 times 9 squared.
E squared. We never say e to the 2nd power. Now, which one of those is the base?
E.
Which one of those is the exponent?
9.
Look at you guys go. You already know 2 questions on your test.
How many questions were you?
45,472.6.
Well, then we made it 0.
Are we ready?
No.
Not at all? Okay. Why are we not even close?
Not in the vicinity.
Does anybody know the first rule? Multiply. Look at you go. Take a point.
Oh!
Remember, you can't go over today. Are you ready yet?
Where is that? We didn't even get a point.
Oh, I got one. It's somewhere around here. I have you asking me. So.
Oh, thank you.
Alright, so turn your paper back straight up. The first rule that we're going to write down is multiplying like bases.
Wait, so now we're straight up and down? Okay.
Yes. Now, what does it mean when it says that they are like bases?
The bases are the same.
So, like A and C?
Yeah. No.
A and B?
No.
What would it have to be?
A.
What would you do with the exponents if you multiply like bases?
Add them.
Add them. Take a point.
Oh, I was gonna say.
So, stop. So our first example that we're going to do is j cubed times j to the 5th power. What would that become?
J to the 15th power.
J to the 8th power.
J to the 8th power. Take a point. It's multiplying like bases. You add the exponents. Yep.
I multiplied today.
I know.
That's so fun.
I know.
So you just add.
Yep.
I remember this from last year.
Yep.
I don't.
All right. Are you ready?
Same class.
Yeah.
Are we ready? All right. So now open this. We are going to do examples over here, and we're going to write our homework over here. Magic. Yep. Yep. So all I did was pick up my crease and fold it over. Now, what did we say we do when we multiply like bases?
You add the exponents.
Add the exponents. Let's write that up there. Add the exponents.
Isn't it a whole different set of rules for
Yes.
right?
Yes. So if I say, here's my first example. A cubed, b to the 9th, times a to the 6th, b to the 7th. Now, would I combine the a's and the b's?
No.
That's physically impossible.
So what would I combine?
The
exponents.
The exponents of the what?
Like times.
Of the a's, of the like terms. All right. So what would a cubed times a to the 6th become?
A to the 9th.
Take a point, Caitlin. What would b to the 9th times b to the 7th become?
B to the 16th.
Very good. Take a point.
Who?
Both of you.
Where are E to the 16th?
That's it. That's all you do.
What's the answer?
So
Do what?
So there.
I can't hear you.
You say we do.
I still can't. Okay. All right. So all you do is you multiply that. If I have to look in y'all's general direction one more time, you're out. Out of the room. So you multiply the a's together. And since you're multiplying like bases, you added the exponents. 3 plus 6 gives us 9. 9 plus 7 gives us 16. So you multiply like bases, you add the exponents. That's why we wrote add the exponents. So what if I wrote this as an example? Is it though?
No.
Nothing is hard.
You did the same thing.
So when you multiply like bases, what do you do to the exponents?
Add them. Is there always an additional?
Tomorrow y'all are separated.
No. I think I know.
What do you think we're going to get? What are we going to get for the exponent of x?
8.
Awesome. Take a point. What are we going to get for the exponent of y? Raise your hand, don't scream. Avery? And what are we going to get for z? Raise your hand, don't scream. John?
4.
Why?
Because there's nothing by z, so it's just 1.
And 1 plus 3 is?
4.
And that's all you do!
Yeah.
It's easy.
I know.
X, 8.
I don't know. Just listening to Tyreek. How is it 8?
It's not. It's
What should it be?
It's 7.
7.
Take a point for correcting it.
No. How? Oh, okay.
I say no to your own point.
Oh, I did it right.
Alright. The next one that we're going to do, if we've done multiplying like bases, what are we going to do next?
Subtracting.
We did dividing. And what are we going to do to the exponents on dividing?
Subtraction.
Yes, take a point.
Take a point.
Alright. Dividing like bases. So, will I do anything if I divide A by B? Will I do anything to the exponents if I divide A and B?
No.
Why?
Because they're opposite bases.
Because they're the same exponent. Oh, they're opposite.
Alright, so if I said, I haven't used M today. M to the 9th divided by M cubed. What would I do with those exponents?
Subtract them.
Subtract them. So when you divide like bases, you subtract. What's 9 minus 3?
6.
That's it. That's all you do. You pretend like this bar right here
The subtraction.
It's a subtraction sign. Does anybody know what this bar is called?
The division line.
Starts with a V.
A verb.
Very straight line.
Vinculum. Very straight line is good. It's called a vinculum.
Binoculars.
Alright, so open this guy again. So when we multiplied like bases, what do we do to the exponents? When we multiplied like bases, okay. When we divide like bases, what do we do? Subtract.
We've been going for a good 15 minutes and 31 seconds. Killer.
Y'all can let him in. He's not a killer. Or y'all just sit there and look. Thank you, Kobe. Take a point.
Kobe Bryant.
I look, but we obeyed your rules. You said we don't open it.
I said you could get it, though.
Well, nobody in here is famous as you, so.
Haha. You're so funny.
I must speak as the whole class is of that.
No.
We're not laughing.
Alright. Now, would we combine Y with anything on this one?
No,
Why?
there's no other Y.
Because there's no other Y. So when you divide like bases, what do you do to the exponents?
Subtract them.
Alright, what's 7 minus 2?
5.
So we have x to the 5th. What do we do with that y squared?
You just bring it down.
It's Y2.
You just.
It's not y2. We're not at bingo. And what's 9 minus 5?
4. Well, Z4.
It's not z4. We're not at bingo. Z to the 4th power. Did you know at bingo they say b4, n9?
Well, yeah, but like.
So it's like a bingo. There's nothing you can say back to that. Just
Yes,
stop.
I can, because
No.
there's no Y, X, or Z in bingo.
Congratulations, but you still don't say it that way.
Big X.
All right, you have 4 homework problems, 2 from each section.
It is? Uh-huh. Oh.
It is. No, it's 4.
Oh! Well, can we take a picture of it? Will you put it on Google?
Yeah, keep it on Google.
I will.
Okay. Everything will go cut.
Oh, well.
She's the best.
Have a good day.